In the previous videos, we were working with evaluating algebraic expressions, and of course this required us to simply plug in a number or substitute a number in for the given variable. In this particular video, in this part of the lesson, we're going to actually work on simplifying algebraic expressions. So our task is going to be more geared towards making the given expressions a smaller, kind of whittling it down, if you will, to a less of a term. So if we look at this, we first of all need to start by simply understanding what common terms are. So to simplify, we need to combine like terms. And so if we're looking at like terms, we're looking at things such as x plus 2x. Since they both have x to the first degree, and this is an understood 1, then we can simply add that to get 3x. So 3x would be the simplified value. And of course, in order for it to be a like term, the exponent needs to be the same. So if we had x squared plus x squared, we would get 2x squared. And again, that's because we were adding the understood 1s in front of each of these. This can also work with square roots. So if I had 2 times the square root of 3 plus 3 times the square root of 3, the square roots of 3 simply act as a combined term, so a like term, so we could simply add the 2 and the 3 to get 5, and then the square root of 3 acts just like the variable does. Now, if we had x plus 2x squared, there's nothing that we can do with that because the x and the x squared are not like terms. So the important part here in this part of the lesson is just to be able to identify which terms are like terms and which terms are not like terms. So let's take a look at a couple examples. So if we look at example number 4, we have a textbook way of looking at this, and the textbook way is they simply factored out the common x monomial and then added the two numbers together. This is not a necessary step. I'm not going to require you to do that. I think that you're aware enough that you can just simply add the 7x and the 4x and go straight into 11x. So if you want to take that route, that's preferable to you, that's the route you need to go. And so you can see in part B that we grouped the common terms together. So the n squareds were not next to each other, and so we grouped them so that we could get common terms. Again, if you can just simply recognize that the 3n squared and the negative 1n squared are going to combine together, there's no need to group them if you feel like you can keep that straight in your head. So some very straightforward problems so that you can just get a little practice simplifying some basic algebra problems. So if we take a look at sample problem number 3, let's work part A, B, and C. So go ahead and pause the video at this time and then come back for the demonstration. So on part A, the very first thing we need to do is the distributive property twice. So we're going to start with 4 and distributing 4 to each part of the parentheses. So I'm going to have 4x plus 8. Then I'm going to distribute the entire negative 2, and that's going to give me negative 2x minus 4. Now here you can do as much detail as you feel comfortable with, or if you feel comfortable doing some of the work in your head, feel free to do that. But if you wanted to, you could either add the 4x and the negative 2x and just simply get 2x, or you could reorder everything to give yourself a better sense of what's going on. And so we're going to be left with 2x plus 4, and since 2x and 4 are not common terms, we can't combine those like terms. Okay, so that's a good start. For part B, we're dealing with j, which is kind of a difficult variable to see, but we need to really kind of group off the j's and separate the j's squared. So we're going to have negative 9j minus j. So negative 9 and negative 1 gives us negative 10j plus 7j squared. Now, if you stopped right here and left your answer like this, that's fine for the time being. Later on, when we get into polynomials, we will make sure that we put this in standard form, which would have the highest exponent first. And so that's a good habit to go ahead and get into. So our answer should be 7j squared minus 10j. So if we take a look at this last problem, again, we're going to have a couple of distributive properties to take care of. So we're going to start by distributing the 7. So I'm going to multiply 7 times x squared, and then times the negative 3. Then I'm going to distribute the negative 3 times x plus 4, so that's going to give me negative 3x minus 12. Now this is a situation where the x squared and the x are not like terms, so we just go ahead and write them in descending order of exponents. But the negative 21 and the negative 12 are like terms, so we can combine those to get negative 33. And so that is our simplified algebraic expression. Okay, so that is just a quick look at simplifying expressions. This should be a review for you from Algebra 1 and Pre-Algebra. And if you have any questions, be sure to ask your teacher. To finish Lesson 2, we're going to look at an application problem, or as some of you may know of, a word problem that basically takes a real-world scenario and applies the principles that we've been working on in the lesson. So in this particular case, in example 5, what we're looking at is buying some movies on DVD and writing an expression that lets you know how much money you have after you finish buying your movie. So if we start with $50 and they cost $15 a piece, we need to write an expression that would let me know what amount of money I would finish with, and depending on how many movies I buy. Now, we really have two parts to this. We have the, if you will, the A part, and then you have the B part. So the A part is going to simply ask you to write the expression. The B part is going to ask you to evaluate the expression after you've written it. So we can start very simply right here. So what we have here is a verbal model, and we can write it in words what we're actually physically going to do mathematically. And so we say we're going to take the original amount minus the price per movie times the number of movies that we've bought. And so of course we're writing an expression, but of course we want to write a mathematical expression. And so if we take the words and replace them with numbers and variables, then we can convert that to a math model. And so it's always a good idea to write a mathematical model anytime you're doing a word problem or an application problem. Now, it just so happens that in this case, the mathematical model is the expression. So our algebraic expression is $50 minus 15 times the number of movies that we've bought. And so once we have the mathematical model set up, we can then evaluate it for different amounts of movies being purchased. And so we want to evaluate this expression for 2 movies being bought, and you can see that we have $20 left over at that point. And of course, if we buy 3 movies or DVDs, we will have $5 left over. So that is a very important part of Algebra 2. Converting all of our basic skills into application of real-world problems. Now, we wouldn't think of buying a DVD as a real-world problem, and a lot of y'all would probably do this in your head at the counter as you were checking out, just to kind of see if you had enough money. But whether you write down the mathematical model or you do it all in your head, the same problem-solving technique and the same thought processes are taking place, and that's extremely important. So let's go ahead and move on down to sample problem number 4. Now, sample problem 4 I've broken up into 2 parts. So go ahead and pause your video at this time and work part A and part B of sample problem number 4. For sample problem 4, it says that we're going to have a choice. We can either buy a CD or that we can buy a cassette for 10 different people. And the CDs cost 13 each and the cassettes cost 8 each. And we want to write an expression that lets us know the total amount that we're going to spend. To start this, the total amount that we're going to spend is the total number of CDs that we buy plus the total number of cassettes that we buy. Now, notice we weren't asked to write an equation which would equal the total amount. We want to write the expression. So there's not an equal sign in an expression. Now, the problem that we run into here is that we actually have 2 different things that we are dealing with. We're dealing with CDs and cassettes, and so we have to have a variable that represents these actual. So if I'm talking about the number of CDs, maybe I just want to use the value n. So if I'm doing that, how do I represent the number of cassettes without using a second variable? Well, it told us in the problem that we had 10 people to buy for. And I'm buying either a CD or a cassette. So we know that if I bought 4 CDs, so to speak, that I would have 6 people that I'm buying cassettes for. So cassettes is actually dependent upon the number of CDs that I buy. So what I'm going to do is, since I'm buying for 10 people, I'm going to subtract the number of CDs that I'm purchasing to represent the number of cassettes that I'll be purchasing. So we call this a dependent variable, and we'll talk about dependent and independent variables in upcoming lessons. So let's take a look. This variable model that I've written down represents the total cost of the number of CDs and the cassettes that I'm going to buy. Well, the CDs cost $13 each. So if I take $13 and I multiply it times the number of CDs that I buy, that's going to let me know how much I'm going to spend on CDs. And of course I can do the same thing for cassettes. Cassettes are $8 a piece, but cassettes are not represented by a single variable. They're actually represented by another expression. So I've got to include that. And so that tells me that it's $8 times the number of cassettes. And of course the number of cassettes that I buy is dependent upon how many CDs that I purchase. And so here we have an algebraic expression or a model. But all of our models should always be simplified as far as possible. So we need to go through simplification of this algebraic expression. So I'll start by distributing, and then I'll combine like terms. So 5n plus 80 is going to represent my algebraic expression for this model. Now, the second part of this problem said to evaluate the expression when 4 people get CDs. So I'm going to take 5, and remember, n is represented the CDs, and so now I can just simply simplify this. And what this tells me is that I'm going to spend $100 if I buy 4 CDs and thus 6 cassettes. Alright, very good. Hopefully you managed your way through that part. Okay, part B is similar type problem where we're dealing with buying books. So we have $40 and we're buying books at 12 each. So this is actually a little bit more straightforward because we don't have 2 separate items or 2 separate variables that we would have to be dealing with. We only have to come up with one particular variable, and that's the number of books that we're going to buy. So it says write an expression that shows how much money you have left after buying n number of books. So we know that n represents the number of books that we're going to buy. So if we start with $40 and we spend $12 for every book that we buy, we'll have our expression representing the amount of money we'll have left over. Notice we did not use an equal sign. We were working with expressions and not equations. Now it says to evaluate the expression if I were to buy 1 book, and then again if I were to buy 3 books. At 1 book, I'm going to spend $28. And I can evaluate that same expression if I were to buy 3 books, which would give me a remaining $4. So if I buy 1 book, I'll have a remainder of $28 left over out of the 40. If I were to buy 3 books, I would simply have $4 remaining out of the 40. So those are 2 good application problems of simplifying expressions and evaluating expressions, both done in the same problem. So very good examples. Those are the types of real-world expressions of mathematics that we want to try to get good at. So very good. If you have any questions, be sure to ask your teacher.